Hello dear potential great engineers. In this video we are going to learn what is Thevenin equivalent of a circuit, and usually it might involve, and it will involve, lots of calculations, but in this case I selected the simplest circuit you can ever find for this topic, because this one will pretty much involve no calculations. So if you have problems with the concept, you'll understand it here. So let's get to business. So what Thevenin equivalent circuit is, basically you want to reduce this circuit to the point where you just have one voltage source, and this will be V Thevenin, and one resistor, this will be R Thevenin, and here you will have some load. And what does this mean is that whatever ohms you put here, the currents through here will be the same as currents through here if you put the same ohms here and same ohms here. Now it may sound vague, but I'm going to solve for Thevenin equivalent circuit, and then it will make a good sense. So what we first need to do is to find R Thevenin. So what R Thevenin means is basically finding the equivalent resistance of a circuit. And how do you do is very simple in case you have only independent sources. So it is a rule that you replace a current source with open circuit, so you'll have something like this instead of current source, and you replace voltage source with short circuit. So basically you put wire instead of voltage source, and you put empty space instead of current source. And now from here, if you had some complex stuff, you just have to do adding resistors in series and in parallel, and eventually find R Thevenin. But in this case, as circuit is super mega ultra simple, the R Thevenin will be 4 ohms, since if you put load here, the current will go like this, and it will never ever come here, since we replaced current source with open circuit. So current can't just do something like this and appear here and continue. It can't. So R Thevenin in this case will be 4. And I think it's very simple, because this is kind of only thing the current has along the way, so R Thevenin will be 4 ohms. So what you need to memorize here is that you replace current source with open circuit and voltage source with short circuit, and then find the equivalent resistance. Okay, let's remove this one, and now we need to find V Thevenin. So let's do it. And in this case, this one is also very simple to find, but usually it will involve more calculations. In this case we still replace this with nothing, and since we have no wire here and we have V Thevenin here, which is basically V open circuit, you might also see these kind of notations. And so basically you need to find voltage across A terminal and B terminal, and in this case, as we have open circuit here, the current will not be going through 4 ohm resistor, hence we could redraw this into something like this, and just finding the voltage through here will be the Thevenin. And let's do it, but there's pretty much not much to do because we have just a voltage source in parallel with resistor and current source, and since these are in parallel and the only voltage source is this one, the Thevenin will also be 10 volts. So we have Thevenin is 10 volts. So basically in this exact case we did not need to use much tools like Kirchhoff's law, nodal analysis, mesh analysis, or anything to find Thevenin or Thevenin, but usually you will have to do that kind of stuff. And as you can see, in this very simple case, we found our equivalent circuit. So let's replace this with 4 ohm and 10 volts, and we can say that this circuit is equivalent to this circuit. And what now does that mean? As I said in the beginning of the video, if we put 6 ohm resistor here, for example, the current through here will be the same as if we had 6 ohm resistor in this circuit. Although these and these look completely different because it is Thevenin equivalent circuit, that's exactly what's gonna happen. For same values of resistances here, we will get same voltage or current across this load, and this one is called load. You should memorize these two. So now let's check that stuff is correct. So in this circuit, current through here by Ohm's law would be like this: I equals 2 V over R. V is 10 and 10 plus 10 for resistances is 10, hence we will have 1 ampere. So that 1 ampere is going through here, and I say that 1 ampere is going to go through here too, and let's check. So I have a circuit simulator here, and this is the exact copy of this circuit. As you can see, everything is same, and this representation or display is different, but it is a voltage source equivalent to this one. And as you can see down here, along this wire we have 1 ampere going through. It says 1000 milliamperes, and 1000 milliampere is 1 ampere. So that's it, pretty much. So we found Thevenin equivalent circuit for this circuit. Thanks for watching.